and hello, and taking care of people. Good morning, everyone. I'm going to present the research about that is famous for contested revision for the human of ideas. Outside, so we can understand myself, Dr. Time with the this is a content of what I'm going to present here. In the time with children, resulting in economic and products. Basically, I use the one of the most important human mode to develop a human routine and develop interpret the life. I don't understand navigation the driving car and manual. I get the checking and then the do it. But one is the modern, the genuine appeal. In the modern, we have a really require more detailed parameter I didn't like the parameter and minimum whether in a village we have required only in the place or I under the location I give the what the motivation behind it. Generally, a million ways and methods fully depend upon large volume labor with the annotation of the great solution in the IU is the different and time consuming task. Even with the large data sets available in the public domain, there is still issue in the emergence with graduate illuminating condition and environmental issues. Today, with them from a service provider, learning is the one of the most promising challenges. A self-perform is featuring model on level data to learn and effective representation of the input images. Next, this is the whole architecture. What do we have adopted to develop on the first stage? We have developed some key generation. In the key generation, we have used data augmentation techniques to no internet featuring and second one, we have implemented the fund community with the small set of label data that is together and we have developed the direction model. This is the important architecture. What we have Canada within the new apply a civilian to security architecture. And we have applied various combinational dilated communication networks like electron electrolysis. Then we manipulate all the feature map and then we apply a global average pooling of everything. Then we identified a latent feature represented. Basically, we advantage of the dilated communication system because we can have larger representative area without compromising complexity of the model. Like, while the future language we have used in normalized temperature scale from the to the next to different ways of data augmentation techniques. We have applied normalized cost in temperature which is equivalent for 2 equations. The final loss function we have applied a Hubble loss function which is the combination of mean square and MSC loss. It's the next we have used a well-known public awareness that is called idiot as the great data which contain around 10 lakh images and from 110% with different 18 cameras. Data they cover a large scale of headboard and head development which means it is good choice of developing a generalized solution. This is the fundamental setup the future to top user and label the first immediate get directed and second third. So two different versions of data movement. Basically, we have applied two types of data movement techniques. First is for Videonun sakınımını var. Canlı videonun we have applied sort of bana 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 really in strong representation we have applied some kind of geometry rotation like rotation is together and many more. Next, father related the model we have applied when and and our model is able to generate the new identity within then move to problem whether that is God simply contract to get the model. The result they were so and from the we get the our model perform better than other popular product necessities. Able to show the ability of different lots ones. Again, we can do our conceptual basically we have developed a new kind of conceptual which handle redundancy as well as redundancy of two different types of data implementation techniques. The other dominant network in Latin America learning for I get visited global model taken on Egypt when non-Egypt has data computers will overlap our global workers on cross the dataset as well as real-time identification. Next, the data economic next, and thank you.
Okay, so you have questions? Last questions. Queries. I just ask you a simple question.
Yeah.
So when you are measuring the angle, is it a 3D angle? Three-dimensional angle? 3D angle. So if there is no other question, then we will invite the next speaker. And begin the speaker. Preparatory 134. I behave. Behavioral analysis using IAS methods. So Baba Vijit will be presenting this paper.
Good morning. Myself, Karuna Vijay. My teammate is Sanjana. And under the project guide is Akshay as assistant professor. We are coming in Amrita Vishwakarma Mysore campus students. Our topic is behavior analyzing using high-grade metrics. This is a problem definition. The goal of the study is to analyze the behavior of a person using his or her high-grade metrics with the deep learning techniques. And this is monitor someone to eye movement and using the data to analyze several facts of behavior. Includes problem solving abilities, tensions, relaxations, and all. In order to, we have to monitor to analyze the person behaving and eye movement also depending that. Then the object is to get inside the person behavior and develop the predictions about the future conduct using the data obtained from the eye-based metrics. And object is our project object is to identify the eye-based metrics using people detections, fixations, and all. And we can visualize the eye-based features, scan path, heat map, and all. Then we can establish the relationship between eye-based features and the person behavior and emotions also. And we can classify the eye movement based on the person eye-based difference. This project is mainly implemented the behavior of the student, study of the eye movement. System analysis, here we have data collections, data pre-processing, data analyzing, model development, model validation, and model deployment. In data collections, we are recording the positions of and movement of the person iris and data pre-processing to ensure the more accuracy of the data. Data analysis means to identify the patterns and correlations between the person eye movements and emotions. And model development is to make predictions about the person behavior and also emotions, feelings of the person. And model validation is using the cross validation technique to ensure more accuracy and reliabilities. And model deployment is a real world scenario. This project is real world applications to collect the data and predictions about the person behavior. And feasibility studies. Here, technical feasibilities, economic, market, and operational feasibilities. This is system designs. Here, live videos capturing the systems. And here we are classifying the features, eye-based features, fixations, cascade, and people detections. And also we are visualizing how the heat map and scan path to extract the facial landmarks. And we can classify using conical reflections based on the computations for eye movement. And here mainly we are classifying two features, sad and depression to classify the behavior. Model phase part-wise description of the systems. Eye track devices, data acquisitions, here cascade classifier, heat map generation, scan path analyzing, and data visualization, modern developments. Mainly this type of things we are including for implementing the applications, mainly heat map and scan path for the to collect the data, record the positions of the eye movements, and we are classifying the eye movement based on the person behaviors. This is system. Exciting system is functionality. In image A, the videos capturing, live videos capturing, and also deep lab DLC for visual entity for facial landmarks. And GraceNet is here is additional artificial neural networks for extracting the landmark positions of extracting the face and emotions. And we can estimate the point of locations of the eye movements. Implementation issues, the privacy concerns, data quality, model accuracy, deployment challenges, and integrations with other systems. And this is our data sets. Two data sets, sad and depressions, we are using classifying the behavior. This is the implementations. And conclusion with statistical analyzing. Here, total participants we are taking 24 and divided by 12 SAD and 12 depression classifications. And overall accuracy 93.35% is SAD depressions, SAD feelings, and overall accuracy in depression is 93.765. Result achieved in heat map and scan bar classifications, and result overall emotions in SAD and overall accuracy of SAD also, and overall depressions and accuracy. This is a reference. Thank you.
Yes. Go back to your map slides. Yeah, so can you just explain like what is the heat maps are related? So, I'm not understanding like
So here we are taken two images
yeah.
for sad and depressions. One image is sad images, this we taken, and another image is also there. Dog we are taken for that depression part, for classifying the depressions. Looking at images, we should feel that that is what feeling we inside feeling that in looking the images, sad or depressions.
And next slide, please. So here, the accuracy slides. Here we just show the position record as well, like the false positives, false negatives as well. The false positives and false negatives as well. If you show like the sad means is sad 93% means
So
sad.
you're asking your neutral level.
No, I'm saying accuracy. As metric you use accuracy, right? You use some other metrics as well.
Okay.
To show and align for results. That's the suggestion.
Okay. Okay. So I'll
Thank you.
let's check.
The question. Okay, so what he asked is still we are not clear to me. If you go back to the previous slide, your own face was there, right?
Yes.
So just go back to that. Not that. Genius. Your identity, no. Where your face is there. There was some face and some. Yeah, this is not your face.
Yes.
That's correct. Okay, so basically you have identified some green rectangles, okay? And there the rectangles are fixed around the eyes. But here it is on the chin and on one eye. So one eye is missing. So that means what are the purpose of the rectangles and how are they fixed? Can you explain that?
So in any ways we can face is detecting, sir.
Okay.
Yeah, we are live videos taking. Then the video is capturing that. We are taking screenshot and putting into that visualization part in the coding.
No, my question is that when you are fixing the rectangles, that is basically some attention part, right?
Yes, sir. We should be in both eyes detect.
Okay, so this is basically not a desired detection on the right side. That is what you want to say?
No, it's down part is showing.
Yeah, that means it was intended to be on the eye, but not there, right?
Yes, sir.
But on the left eye, not on the left eye, basically right eye. So if you see, there is a circle, white circle, and in the circle there is a center also, right? And there also there is a circle in every rectangle. What does the circle imply, and what is the white dot inside? Is the center?
Inside the people detections, we are detecting, sir.
Then the people is not rightly detected here.
Is only one eye is detecting that in my images. Second.
No, but the center of the circle is not the people anyway.
Yeah, I think is either the heat map is not properly generated
Yes, sir.
or there is some issue with the planet.
Yeah, maybe the explanation there is something, right? The explanation is something else with the heat map. Isn't it? Because you see that the circle is not centered, rectangle center is not the circle center. They are also here also. Neither case.
That's what I was asking, like you see the false positives and false negatives, right? Probably this is either false positives and false, they are showing the wrong pictures. That's the point. Probably this is a misclassification one, that is not directly picked up by your model. So you do some relook into the reference, then
Okay.
Yes.
Thank you.
Thank you.
Next one will be presented by Sharthuk Akhre, Sharthuk Akhre. And the title is Engage That Real, a multimodal engagement dataset comprising of emotional, cognitive, and behavioral cues in virtual learning environment. Any author of paper 306 is not yet reported to us. Paper ID 306, title is Cortical Circuits of Context Availability. Cortical Circuits paper 306.
Good morning, Chair, professors, and all my fellow researchers. I am Sarthak Akre from Vishweshwarya National Institute of Technology, and I'll be presenting my paper titled Engage That Real, a multimodal engagement dataset comprising emotional, cognitive, and behavioral cues in virtual learning environment. So we'll quickly go through the outline. We'll start with the introduction, the background work, and collecting the dataset. Then we'll talk about the dataset. Then we'll talk about the privacy and user agreements, the current work which is going on, and the references. So to start with, gauging a student's engagement in virtual learning or e-learning platforms has been quite a research. There has been quite a research in this particular area since the advent of e-learning platforms, and it has taken a hit in the recent years. But it was quite in major research in the COVID era, basically when the people were shifting towards the e-learning platforms and the MOOC courses. So what the problem is there in the current data sets is that they are only focusing on singular modalities. That is, major research goes in vision related modalities, that is images or videos. The second modality is log database modality, where you track the interaction with the learning management systems and you do learning analytics on that. And the third is the self-reporting modalities. So what we found out is that these modalities have been quite separate, and researchers have been modeling them in separate areas, and there is not conjunction between them. So here for the first time, we introduced Engage That Real, which is an innovative data set which comprises all the three modalities of emotional, cognitive, and behavioral cues. And we are the first ones to combine these three modalities. So we'll talk about the current methodologies which are going on. As we just spoke, first one is the vision singular modalities, where most of the research has been going on in computer vision, whether it be image related data or video related data. The second is log database engagement detection, where the interaction of the user is gauged. For example, uh, the LMS can track the course views, how many times a particular student has accessed a particular uh, assessments, or let's say the resources for the course material. All those data are kept. And self-reporting, they take basically these two first modalities and self-reports from the user whether he was engaged or not. So we'll dive deep into the most research area, that is the singular modality for vision. So first we have the AppexNet dataset, which is a large dataset with 450,000 images and capturing 11 emotions. We have Belfer's natural induced emotion dataset with seven emotions. The Day2 dataset, which also are in the lines of the virtual learning environment like ours, has video data with four engagement labels and levels, and prediction and localization of student engagement in the wild, which is a video data set which just has one emotion, that is a student is being engaged or not. Similarly, towards automated understanding of student-tutor interaction using visual directed gestures, also has the same emotions of being engaged or not. So the majority of the research is in this area, where the researchers are uh, making new machine learning models using computer vision on these particular data sets. Now, what is the limitations of these data sets? The first one is that the image or video related data sets lack in the integration of other integration of modalities. For example, if you see in virtual learning environments with the four labels that we have taken, the accuracy levels for the models that have been created in computer vision stagnate to nearly 70 to 74%. So we find that there is a need to integrate it with other modalities. In the log database engagement, they are majorly focused on the interaction levels, and that is the reason why it becomes quite difficult uh, to detect uh, to detect the labels for boredom, frustration, or let's say confusion. And in the self-reporting engagement, the problem comes inherently from the subjectivity of the modality. It basically varies from person to person, so it doesn't become quite reliable. So, what is the solution for this? Uh, in a research study by Divan et al., they have basically categorized the engagement detection in online learning into three different parts, that is automatic, semi-automatic, and manual. So the automatic engagement detection relates to the part for computer vision related methodologies, where you can do facial expression detection, gesture, posture, eye movement. The semi-automatic focuses on the engagement tracing, where you trace the interaction with the learning management systems, and the third is the manual one, where you take into consideration the self-reports too. So taking this view into picture, we have created our own data set, that is the engaged at real data set, uh, which in which we integrate the emotional, cognitive, and behavioral modalities, all the three mentioned, and we believe that it will provide richer insights and will reveal more patterns and correlations for further research. Now we talk about how did we collect this data set. So within our campus, that is VN we ourselves built a learning management system, a custom learning management system for a particular course, which was taken up by 25 students for a total semester, and it was made for them to be totally in the wild. They can log in into it, watch the lectures anytime, whenever they want. So we'll just talk about the architecture of our application. So as you can see, this is the particular screen which is visible to the student, where the first thing is the lecture video, where the student watches the lectures that are nearly 40 lectures in that particular course. Then below that are the video controls, where we give the options to play, pause, seek back into the video for 10 seconds, multiples of 10 seconds. And we also give the option to change the speed package to increase it or decrease it. And below that is the webcam feed from the laptop camera of the particular student. And whenever there is an interaction in the video controller portion, that has been sent directly to the server and stored in the log database. And for webcam feed, we are creating sockets directly to sync up with the server, and we are sending the image frames at 10 frames per second on the server, where basically we can stitch up a video and it's stored in the server file system. Now let's see how it visually looks for the student. So this is the particular screen where a student will find the list of lectures, and clicking on any one of it will take you to the below screen where this is the lecture video, the video controller options, and below that is the webcam feed from the student laptop camera. So for the self-reporting modality, at every 10 minutes of the lecture video, we also give an option to collect the feedback for the last 10 minutes. We'll see it in the further slides, how we are collecting the self-reports for the 10 minutes. And also, just as a precautionary measure to not load the dataset with empty frames, we have also deployed on the client side the play space by Google to detect faces. And whenever the face is not detected, we just pause the video, and the the frames are not being synced up with the server. Now we'll look what kind of data we have in the log-based data set that we have collected. So this has been divided into the action which a user does with the learning management system, and the data which has been collected related to that in two particular columns, that is the action and data stored. So if you can see the second row, the quiz and test related actions, this is where our cognitive data comes from. So in every lecture, there were 2 to 3 quizzes that were taken, which were evenly spread out, and which tested them on the previous material which was covered. Not only these quizzes, but regular quizzes apart from the lectures that are, let's say, mid-sem quizzes, end-sem quizzes, all these were taken up for this data within the LMS application. And if you also see the last row, that is the self-reporting log data. This is where our self-reports come from. To see it in much detail, these were the 4 options that were given at every 10 minutes to the student. That is interesting and understandable, interesting but not understandable, not interesting but understandable, neither interesting nor understandable. And we map them to our 4 particular labels as our self-reports. To talk about the video data, or if we can say the frames as image data, we have a resolution of 720 cross 480 pixels at 10 frames per second. So there were 40 lectures in the course, on an average to nearly 46 minutes of each lecture, and was watched by 25 students of South Asian descent, with 17 males and 8 females. Now, the question comes when we are dealing with 3 different modalities, is that how do you fuse this data? So what we have done is that now the 3 modalities are being saved in 2 different stores, that is the log-based database and the server file system. How do we present it to the researcher in one single format? So what we have done is that we have selected only the first attempts for the student watching the lecture. That is the first attempt in the sense that the student can seek back into the video, watch again the video. But we have just taken the first attempts so that we can track the original emotions. And we filtered out all the timestamps, Linux timestamps on that. And according to the subset of Linux timestamps, we queried the log data set and got our log data. And from the log data and the video data, we have merged them into a single SRT file, which you can see in this image. And after getting this SRT file, when you open a video, you can see the student emotions, the attempt number, the Linux timestamps, the video lecture timestamp, the action taken by the student, and also whenever a quiz pops up, if it was answered correctly or not, everything you can see in a single view. So this is the part of data fusion that we have achieved. Now, for annotation of the data set, as it was a quite huge data set with a large set of video segments, we first tried to use the deepface by Facebook, and we took the first three 7 basic emotions which the deepface emotion model gives us, and found out that we had taken one gold standard subset of data set which we annotated manually, and for each of the gold standard data set which corresponded to the labels of attentive, confused, bored, and frustrated, we correlated the 7 basic emotions among themselves. And yeah, gold standard, we have taken a subset and we have annotated it manually. So the first annotator is trained psychologist within our campus. The second is the professor who taught the lecture, and the third is a common annotator. And the maximum of it, I mean, to if all three are different, we take the maximum vote of which is the emotion related to that particular trait. Right. Yeah. So that case, in that case, we took another annotator and filed it. So there are ways to mitigate those problems. And we basically correlated with the deep phases 7 basic emotions and found out that there was no particular density of let's say for attentive, there is no density of, let's say, if a person is neutral and basically happy, he is being attentive. We didn't find any correlations among them across attentive, confused, bored, and frustrated. So that is the reason why we need to scrape this ID. Second attempt for annotating the dataset was using the pseudo labeling. So in the study by Mingetai titled "Why Pseudo Annotation, Pseudo Labeling in Semi-Supervised Learning Algorithm is Effective," they found out that pseudo labeling is quite effective. So that is the reason why we took a mobile net model. We trained it on ImageNet dataset and fine-tuned it on the Day2 dataset with our 4 labels, and use that model to predict the labels on our dataset. And we also use the self-reported engagement logs. And whenever there was conflict among them, we did manual intervention and basically got the labels for our dataset. Now to see the results, we have nearly 59.2% of the frames of attentive label, 21.9 in the confused label, 10.7 in the bored, 8.2 in the frustrated. We also did a separate study where we again took a gold standard in the same process that I just discussed with the 3 annotators, and found out that the pseudo labels on an average matched with the gold standard with only 56.3%. So there is a need to more scrupulously do this annotation process, which we'll get back to it later. Now we'll discuss the challenges that we faced while creating the dataset. The first one is the low illumination, which basically comes inherently in datasets when you give the functionality of to be in the wild, where the user can watch anytime and anywhere, which basically affects the post processing of these images. The second is the phase occlusion, where the annotator cannot take a stand of which emotion is this basically. And the third is the variation in emotions. Basically, in a short period of time, if the emotion varies quickly, that also poses problems with the annotators of how to annotate. The privacy and user agreements, each participant had given a signed consent of recordings to be captured and further and used for the further academic research. If it was not granted, the videos were not acquired, and all the subsequent users will not reveal their personal details or any identity. And this data set is currently be using within our institute. So we have a restriction on that. So now moving to the current work, as we have seen the limitations of self-reporting and all the other two modalities, we are in the process of doing the total annotation manually. As we have seen the result from our gold standard. So what we'll do is what we are currently doing is that for each particular video snippet of 10 minutes, we are taking 10 to 12 crowdsourced annotations, and we'll be using the wisdom of the crowd to annotate it. And for that, we'll be using the David Steen expectation maximization algorithm to boil it down to a single label. So these are the references for our research study. Thank you so much. Any questions?
Questions, please.
The data set available online?
No, currently we are tackling with the privacy issues, and the annotation part is also under it. So
Can you write a mail to you?
yeah, sure. The major thing comes from the privacy issues. We have tackled them to be used within our institute. We'll have to do more work on the privacy issues first, because the data sets like this, privacy issue becomes quite a task in this.
But for the research purpose.
Yeah, sure.
So in one of your previous slides, you mentioned three challenges. Is there any way to solve it? Did you, work in it or?
No, we have kept the data set as it is for now, but I believe there are computer vision methodologies which can tackle with low illumination. Uh, but with the face occlusion part, we cannot do anything. We will have to scrape those frames or those part of the video segments.
The third one?
Variation emotions we are tackling with the help of basically we will take psychologists who are working currently in the process of basically in this area, psychologists who will have more weightage in annotating rather than other two annotators. That is the process.
Okay, so I have one question. Like, there is a kind of confusion while annotation, right?
Yeah.
Maybe. Depending on the situation, like the face is not giving any clear impression, like whether it is confused, bored, or maybe frustrated.
Yeah.
The difference is basically very subtle.
Yeah, very certain.
Very subtle. Now, think that particular piece of the lecture, you have 25 students. So for 20 of them, you are sure that it is a kind of frustrating lecture. Okay, then maybe for the other 5 also, the vote should go in favor of frustration.
Yeah, that is where our log data comes into picture. Let's say you're watching a lecture video, and in between we get logs that there have been seeks to previous section of the lecture. Okay. And there have been quite a significant number of people. Let's say out of 20, there have been more than 10 people who have been seeking previously into the lecture. We will find those patterns that this part of the lecture is confusing to the students.
Yes.
This pattern revelation can be done using our log modality.
Yes, but you have not done, right?
We have collected it.
Okay.
So
Okay. So you mean to say that that can be used?
that can be used. Yes.
Yes. And another thing is that about the speaker or the professor, the teacher who is teaching that, and students are attending that, then it may also vary mm, upon the section of the students who are attending. Right?
Yeah.
Is it
Yeah, the demography of the students.
demography of the students?
Yeah, so we have taken, I mean, the class consisted of nearly 100 students. We have taken the demography of like from the 10 pointers, some people,
Yeah, right.
the nine pointers. So we have taken 25.
So those kind of metadata are also present.
What?
So
Sorry.
that metadata, like additional data,
Uh,
like as you told,
yeah,
the
so
demographic data.
it was quite uniform. We haven't added it into our research, but we can give you the data related to that.
Okay. If you have any question, you can ask. Otherwise, go to the next speaker.
Thanks so much.
Okay, thank you. Thank you. There, Bhargav, representing eye game, cognitive game analysis through eye movements of the player.
I'm Shreya Bhargav from Ulta Vishwavidyapitham, and the title of my paper is I Game Cognitive Game Analysis through Eye Movements of the Player, and I'm doing this under Mr. Akshay S. This is the content. Introduction. Cognitive game analysis through eye tracking is an amazing area of research that aims to understand the cognitive process during the gameplay, and it helps us to provide the insights how the player think while playing the game and interact and perceive the game. This helps us to optimize and enhance the game while collecting those data. The objective, the aim of the research is to provide, collect the data for 20 participants while playing a simple game which is popularly known as tic-tac-toe, and collect those data and analyze and classify them in three levels. That is beginner, intermediate, and expert. The proposed methodology is game development, playing a game of cognitive analysis, as I told, tic-tac-toe, and measuring those eye movements also, like the gaze and the movement, mouse movement, the data collection and feature extraction. The collection of eye tracking of the participant by extracting the features such as fixation as well as saccades. And analysis is done either by machine learning or the deep learning algorithm. Here, in this research, I have used machine learning algorithms. The classification, classifying the participant into three classes: beginner, intermediate, expert, and also visualization done. For example, heat map. And this is the architecture of the paper. Working. We have played the tic-tac-toe game, and we have, as I mentioned, have mentioned the website here from where we have taken the content of the game which is supposed to play, and the participants are made sit in front of the laptop, and we have used the laptop camera, which is the simple camera integrated camera, to collect those eye tracking data, so like eye gaze as well as the mouse movement. And we have used the X and Y coordinates in order to collect those data. In addition to that, we have also collected the duration, the reaction time of the participant while making those movements, like placing X and Y in those grids. The next one is the pre-processing of data. It refers to the cleaning and formatting of data, taking out the invalid, inconsistent data as well as making it error-free, and taking out the missing values and invalid data, and also the noise and outliers. Once the data is pre-processed, we have used six classification algorithms in order to get the accuracy as well as the classification of the participants. This is the heat map. Heat map refers to the graphical representation of the gaze points, and the areas with the highest frequency of gaze points has a warmer color, and the areas with the lower frequency of gaze points has a lower color. And we also use the decision result and F1 score in order to get those details checked. The difficulties or the challenges we faced while doing this was that adjusting the camera level to the eyesight of the participant. It was very difficult because it may vary from one person to one person. So we had to provide a proper seating position and in a controlled environment. The lights can affect the glare and the eye tracking data. Layer wearing glasses also is one of the challenges we faced during the uh, project. Thank you.
It's a quick presentation. Anyway, so questions, I have questions about the technical details also. So I have one question. So if you go to the heat map, now you see it is basically a kind of the final heat map you are showing, right? But it is basically transient, like it is changing with time. The heat map is changing with time. When the player is playing the game, say if the player plays the game for 2
So
minutes.
this is the heat map on the data that has been collected over there. We have provided the heat map on the XML coordinates.
It's not important, but this is for a particular game when the player is
Yeah,
playing.
yeah. It's after the game is finished.
After the game is finished. So now you see that the impression on the heat map, basically, this is changing with time when the player is playing.
Yes, sir.
So that change is also important.
Yes, sir. But the thing is, the most of the time the participant refer to the middle place or the place where they have to make the place the XMO elements. So the most number of times the heat is concentrated while selection process takes place. So like selecting the grade, then the heat map will be more on the color.
So this you have shown for a particular
particular
instance of the game, right?
Yes, sir.
Now for another instance of the game, the heat map will be different.
Yes, sir.
So it depends on whether
This
these symbols
is
are
actually
placed.
the example of a single player.
Single player, right? Single player, a single game.
Yes, sir.
Now, what I'm telling is that it may happen that for a different game, maybe for the same player or different player, the heat map may be same, but the game may be different. Means the steps of the game may be different.
Yes, sir. Sir.
So how do you recognize that? Unless you consider the time.
Consider you have also consider the time reaction time, sir.
Not reaction time. I am changing. I am talking about
Okay,
changing the heat map with
playing
respect
the
to time.
single place. Okay.
I am telling about like the player and the adversary. Both will play 4 times here, right?
Yes, sir.
Both will play 4
Sir,
times.
actually it is
4 or 5
played
times.
against the computer, not two players.
Huh?
It's played against the computer.
The computer is the adversary, I am telling. So the player and the computer is nine places are there. So there will be 4 plus 5. That will be the number of steps. Now, after every step, it is changing.
Yes.
So it is basically depending on the combination of the steps. So that combination
And
also has an effect on the heat map.
yes, sir.
But you are considering the final signature, not the intermediate
Step
ones.
by step, we have to provide the.
Yeah, that also gives like an idea like how the game is played.
Try to indicate.
Yeah. And just done it for the TikTok,
Yes, sir.
TikTok too, right?
Yes, sir.
Nothing else.
Not it. It can be, if we, further projects, we can use it for chess or crosswords. But the data that will be collected will be very.
This will be a long time game.
Yeah,
This is a short time game.
that's why we choose this one.
But there are also other short time games. Like tic-tac toe 4x4 is also available.
Yes, sir. Shooting is one of the game we can consider, the reaction time we can consider shooting.
Yes, and that may depend on the game also.
Yes, sir.
The heat map may change with the game. Okay, thank you. Next speaker, and that is the last presentation of this session. Shweta Kaman. She will be presenting on cortical circuits of context adaptability, understanding the neurobehavioral mechanisms underlying flexible behavior.
दीपक लैपटॉप का ऑडियो म्यूट करके रखना।
Very good morning, everyone present over here. I am Shweta Kaman, PhD student in the School of AI and Data Science at IIT Jodhpur. And I'll be talking about cortical circuits of context adaptability and try to understand its neurobehavioral mechanisms. So these are the topics I'll go through my today's presentation. I'll first introduce why we need context adaptability, what are the objectives of my work, problem statement, methodology, literature review, task, and the stimuli which I have used, and I'll conclude. So, we all know that decision making is part of our life, and starting with in the morning, what to wear, what to eat, to the significant decisions in our life, we all need decisions, and we all need to be wise. We all need to be wise, and whether it be big or small, it contributes our life, and my research area specifically is wisdom and wise decision making. So, wisdom is not static, actually. It is very dynamic and it adjusts to different contexts depending upon different situations, emotional stimuli. So, there are multiple components and elements of wise decision making, but context adaptability is the main element of a person who is wise. So, context adaptability is to deal with different contexts and to flexibly navigate through diverse perspectives of our life and weigh the pros and cons, and then think about future long-term goals and ethical considerations, and then make some decisions. So, we are in this study, we are just trying to understand the ERP components related to context adaptability. So, these are the problem statements. Existing studies, they have not sufficient literature into the neural mechanisms related to cognitive flexibility, and especially with the wise decision-making perspective. So, we need to study cortical circuits because it can help us to understand like how human beings they navigate through these different emotional contexts, and then how they process it, how they uh, rationalize it and take decisions. So these are some of the literature review. Linguists, they have conducted a meta-analysis of neuroimaging literature. So what they have done is they have tried to study which brain region is affected by the positive and negative effect. And a brain model which is proposed by Kraft, they have suggested that there are multiple interdependent networks of emotions, cognition, and decision making which work together. And Bronze, they have investigated the impact of emotional stimuli on effective picture processing after long-term immobilization, which means that when a person is made to sit for a longer duration without any movement. So they found that long-term immobilization results in emotional blunting, which means that it dulls the emotions of a human being. So these are some other literatures, and Lucina, they have discussed the neural mechanisms underlying the cognitive behavioral flexibility. So all these studies, they have just mentioned that emotional factors are important, contextual factors are very much important whenever we want to study the behavioral adaptation in an individual. And so there are few factors like pictures which they have used but not very much in depth into studying what are the neurophysiological backings of this context adaptability. So in our work, we have developed a new task. We have designed a novel task as well as novel stimuli, and which are some visual cues. So our main objective is to validate the emotional responses of the visual cues. So the cues are categorized into three contexts: positive, negative, and neutral. So obviously, we can ask the participants to rate the valence of the images, but we wanted to validate it through some neurophysiological validation process. So our main objective is that, and the second objective is to understand how our brain adapts to different emotional stimuli and responses. So basically, this is just a pilot study, so that's why we have recruited 8 graduate students only, and this is a picture-based decision-making task. So we have tried to artificially develop some images which consist of stick figures and objects. So I'll show you some pictures. So these are some sample vignettes, picture vignettes. So in each of these picture vignettes, we have not shown any gender, so it is not gender biased, it is gender neutral, age neutral, and it does not have any cultural and elements in these figures. So we wanted it to be culturally bias free. So these are the pictures which we have used. These have stick figures and objects, and each of these images they depict some moral dilemmas. So each of the scenarios they depict some moral dilemmas, and in the pictures, I have mentioned what would you be thinking in this situation. So all those pictures, in each of the pictures, I will not be showing the linguistic components. First of all, we will train the participants. We will give them training session, practice sessions. So the task is all about, I'll show them these pictures. I have total 15 vignettes that we have designed. So we will show each of the pictures to the participants and ask to visualize these and think aloud, which means that whatever is coming in their mind, they have to just speak it up verbally. So the question would be, what would you be thinking in that situation, and what would you do in that situation? Because wisdom is all about thinking as well as yes, exactly. So it's objective. There are multiple diverse perspectives. So yes, so I have divided into three categories here: positive, negative, and neutral. So somewhat we have just, for example, in the red border picture, so we can see that there are this knife with blood stains in it, and here we can see, and money and wallet. So I mean, if in this situation, if the person finds a wallet, what would you be thinking? So this is the kind of negative context which I think, which we have decided. Panel of psychologists, we have validated this, which we call face validation, a psychometric tool. So the green one, this is a positive one because a person is has just dropped his or her wallet and as well as key. So he is nearby to us, and if we find that he has just dropped, then what will you do? So, and in the neutral context, I've just shown that if someone has just seen a wallet which is dropped in a park, which has no identity in it. So it's a kind of neutral scenario. So somewhat like this, I have other scenarios as well. And yeah, this is the task. So participants will be able to see each of these images followed by a fixation. And then they will have to rate how wise do you think your decision is. I mean, after they have talked about their own self perspective about the scenario, followed by fixation, they will be prompted to rate their perceived wisdom of their own decision. So with this, we will get their, reflective evaluation of a person in the form of ratings. So it is a fuzzy one, like between 1 to 10, like up to 5 decimal points. So after that, we will also ask the participants to rate the values of the previous image. And yeah, so this is all about. And we've used 32 channel brain vision amplifier, and also we have study the frequency bands. These are the 6 frequency bands: beta alpha, beta 1, 2, 3, and gamma. And we have, since this is a very small pilot study, but still we have just tried to divide the participants into 2 groups, group 1 and group 2, just to check that if we shuffle the order of these cues in positive, negative, neutral, and then in group 2, neutral, negative, and then positive, then what happens? I mean, when we shuffle the orientation. So we just did this because in our real life we do not encounter these emotional situations in a very fixed manner. So that's why we wanted to shuffle it. And these are the task outputs which we got, like verbal responses in the form of speech of a participant and reflective evaluations in the form of ratings. The valence ratings, like how much negative and positive and neutral is this, as well as the EG signals. And these are the early ERP components. So according, so in the fourth column, we can see the literature references. So all these studies, they have used images, and they have tried to understand the ERP components related to positive, negative, and neutral components. So according to the for the P1 component, which we basically found between 80 to 130 milliseconds. So they found that P1 component was if at 117 millisecond, and what they saw was the amplitude of the positive response. I mean, when the positive stimuli was shown to the participants, the amplitude of the response for that was longer and greater than the response in the ERP component for the neutral stimuli. And they got the L and A, it represents the latency and the amplitude. So they found it at 120, so we found it at 124 millisecond latency, and at the region occipital area. And for group 2, and for group 1, we got the result at 120 millisecond. And we found that the ERP component for neutral is greater than the positive one, and positive was greater than negative, and so on. So in such a way, we found that the N1 component, we found it between 148 to 172 millisecond, and which closely aligns with the literature. I mean, all these are the standard work which has been done in this field, because there are not much research which has been done in this area. And so on, we found the P2 component, N2 component, and P3B component, which aligns with the literature in this. So we can say that these, whatever we have tried to elicit and intend to show from our stimuli, they were actually eliciting the particular intended emotions. Like if we have developed some positive stimuli, then with this we can say that they are actually eliciting the positive emotions. And these are the early components, and this is the later component. late positive potential. So for group 1 and group 2, we can see that for group 1, okay, we were showing them the sequence positive, negative, and neutral. And for group 2, neutral, negative, and then positive. So for group 1, we can see same winnings, but the sequence was different. So for group 1, we can see that the amplitude of the positive is greater than the neutral, and here the negative, negative is greater than the neutral. And in group 2, we can see that when we have shown participants equal negative and then positive, then there is no such LPP found for this between positive and neutral, but we can see it with the negative versus neutral. So these are the ERP components when participants were rating their own decision with respect to each of these vignettes, be it positive, negative, and neutral. So these are the ERP components related to that. Okay, yeah, these are the significance actually, which means that there is a significant difference. Yeah. So we have generated this using the EEG lab toolbox, which is a MATLAB toolbox. So this is for the signal processing and the statistics used in that. And we have also did some regression analysis between the absolute power values, the strength of the signal, and the ratings. Ratings, which means that the reflective evaluation, that how wise do you think your decision was. So we found that the alpha, the absolute power value of alpha band was significant with the ratings for the positive. See, this is the group 1. The first row is for group 1, and this is for the group 2. This is for the positive stimuli. This is for negative, neutral, and this is for neutral, negative, and then positive. So in group 1, we can see that there is a linear relation, of course, and also we found it significant for the absolute power value of alpha as and the ratings. But we didn't find any significance for negative. I mean, when they saw the negative stimuli, when they rated it, and with the other all the 6 frequency bands which I tried to study, that is alpha, beta 1, 2, 3, beta, and gamma. And for the neutral stimuli, both alpha, the power values of alpha and theta were significant, and with the ratings of participants. And for group 2, we found that again theta and alpha are significant for the neutral stimuli. So we can say that group 1 and group 2, the theta and alpha are significant. The power values of theta and alpha are significant with their ratings. So there has to be something with the neutral stimuli. And for the rest of the other part, we didn't find any significance, but we can see that the R square value is very good, and it shows that there is some linear relationship. But we didn't find any significance, most probably because we have very small sample size. So that may be the case. So these are the findings. We found we studied P1, N1, P2, N2, P3 components, which was designed for stimuli in group 1. And we found that positive stimuli, positive emotion stimuli, it led to greater P1 and N1 amplitudes, while the neutral stimuli, they enhanced only the P1 component compared to positive. And P1's occipital region, it displayed the strongest effect. And the parietal and occipitotemporal regions had been seen as enhanced with the N1 responses, and amplified P2 responses to positive versus neutral stimuli We got this in group one. So in group one, during the P2 processing, the front two, yeah, so age group is between 20 to 30.
Why not?
Yes, we can. We are just studying. I have also conducted research on the school kids as well. Because since it is age neutral, so anyone
No,
above
but
18,
experience counts here. Isn't it?
yes, experience counts.
So in that case, basically below 20 and above 30 may have a different,
Yes.
different behavior in your regression analysis.
Yes, exactly. So actually, this was just a pilot study. So we just found some 8 people, graduate people only. But we have also a separate study which is on the school students. And also I will conduct on the professors of our institutes. So that is our plan to make it more heterogeneous. Because the stimuli is as well as it's very age friendly because it has cues which is not that much dependent really. So yeah, so during the pre-2 process, the frontal, central, and occipital temporal regions were most heavily impacted. And larger P3B amplitudes for negative stimuli as compared to the neutral stimuli, and positive stimuli showing larger amplitudes than negative stimuli. So we also investigated the relationship between EG frequency bands, these are the 6 bands, and participants' ratings. So we found that there are significant associations between alpha power and the positive stimuli. And we found that theta were related to the neutral stimuli, alpha and theta power values. So group 1 exhibited significant. We didn't find any significance with the gamma,
The
but
gamma is basically related to
for the high, yes.
sleeping state.
No. That is for the high mental state when we are conscious and we are performing a high mental activity. That is.
And what is alpha?
Yeah, alpha is when we are active, when we are normal, and sometimes when we are close our eyes, but we are conscious. And what you are talking about is about theta, I think. Delta.
I have confused the terms.
Yeah.
There is one particular frequency band that the
Yes,
saints,
exactly.
the saints can achieve, right? So that is possibly gamma or theta, one.
Yeah, but yes.
But it is basically increasing, right? Because you have your conscious level will fall as you move from alpha to theta to gamma like that, isn't it?
Yes.
So theta and gamma, I think one of them will have no impact here.
Gamma should have, actually theta should have no effect. So theta is related to neutral emotions. So in our study, we found that theta means when someone is bored or someone is relaxed.
Relaxed
Actually,
or passive.
relaxed.
Does not
So
mind.
yes.
Does not mind.
So it is very, he is very relaxed. And if you talk about the mind, then he is not using his mind.
Yeah, right.
Huh. So that is for the theta.
Yes. Theta has no effect or no impact on your.
It is, but for the neutral stimuli, which is neutral emotions. So we found significance with the theta and the neutral stimuli ratings, like they were least interested. And we found relation with alpha and the positive ratings. And for the positive emotion stimuli, we found relationship with alpha. But we didn't find any correlations for the other bands. No, nothing. Yeah. So that's why I think we need to grab more data. So since this was just a pilot study and linear regression, we thought yes, since there is a linear relationship, so I think we need to grab more data, and we are actually.
Is that you have only considered the visual unit, right?
Yes, exactly.
Why not text unit?
No, because text it has lots of biasness and it cannot
Lots of
biasness and cultural these things biases. So it will be culturally affected.
But in your locality, it might not.
Yeah, I think the instructions which we will provide to the participants that will depend upon the country to country.
Yes, country to country, but you have taken for a small
Yes.
population in your local school or something,
Yes,
then it does not matter in fact.
Yes, it doesn't matter. So we just want to generalize it and globally so that anyone can use this tool.
Yes, yes.
So that's the main purpose. Actually, we are developing a measurement tool and assessment tool, which is known as psychometric tool for wisdom. So we are trying to assess wisdom, and context adaptability is just one part of that.
Yes.
That is the thing. So the group one, they increase the emotional responsiveness. So with this, we can say that group one, where we have shown the participants positive, negative, and neutral stimuli. So they showed an enhanced adaptability. And group two, they displayed selective emotional responsiveness because we didn't find any LPP for the negative and neutral part. So these are the future work. We are also curating a data set with this. And apart from EEG signals and the ratings and the verbal responses, we are also curating the eye movements as well as the facial expression. So we are collecting, apart from this, we are also collecting this data set. And we are just targeting at least 200 because in EEG studies, it's very difficult to gather the EEG signals. And that's what. These are the references. Thank you so much.
Please.
I have. Oh, very good work. One question I have is that is it because it is a controlled population on which is it possible to parallelly do a psychological test on them like the
Yes,
personality
exactly.
and
Yes, sir. I have done Hexaco actually.
Hexaco, big
Yes.
you have done.
Yes, yes.
Okay.
Yes. So
And,
I've already done that as well as I have done the Raven's progressive matrices, Stroop test, intelligence test.
Look, test also.
Yes, I have done all those things.
And are they part of the regression variables? No,
No, that are not part of that.
they are not part of the.
Yes, so that part we have kept it for the validation of a psychometric tool because we need to show the reliability and validity of a tool whenever we value. So we have just for the convergent and divergent analysis.
Okay.
Huh.
And how, I mean, what was the setup? Like it was a immobile setup or a mobile setup? Because
No, since this is an EEG experiment, so we need a participant to sit in our EEG lab.
yeah, see, and all other motor signals are kind of reduced.
Yes.
Okay, so there is no motor signal interfere, even eye blink and all those are
This is the
cancelled.
gaps we are talking about. Yes,
Yeah.
I understood. But that's the thing. When they will, for example, when they are talking, since the task was to think aloud. So when they are talking, they can see above, but we have just instructed the participants which do not move that much. But there will be bit of saccades, which we found in our eye tracking data as well.
Because what I was looking at the time scale. So the time scale of this positive peak and other
Yes.
that they are matching with the saccades, they are not comparable. Not
Yeah.
I'll not say matching, they are comparable because like usually if the saccades are very fast, whereas the opinion of these are longer time frame. So is it possible to do a time separation, a time scale separation of this and
Yes, we can do that part, but yeah, but the thing is, the standard literature.
okay, it doesn't do that.
Yeah, they do not cross the.
They do not
Yes, yes,
Yeah.
that is the issue, so that's right.
Very good, because it has a lot of potential. I mean, not just this, even for like fitness test and others, professional.
Yes, for educational and clinical.
Educational, clinical purposes, because usually people with a depression history might have a completely different
Exactly.
profile. So, assuming all the participants are mentally healthy and.
Yes, yes. So all the participants are healthy, so that is the thing. And in elderly people as well, we can.
You can, yeah, geriatric
Yeah.
normalizations as well. And very.
Thank you so much.
Any other question? Okay, so can you go back to the regressions analysis, the plots where we have the group one and group two? There, when you are doing a regression, like in the first plot on the left side, there is only one line, right? Because that is basically coinciding with the 45-degree line.
Yeah.
So it is one line flow. Now, if you go for this is linear regression you are doing, right? Now, and for that regression, you have a kind of value also, how much linear it is, like 0.862, that means it is less linear, right? Like that. Now, there is also a kind of inclination of with the 45-degree line, like, right? So, does it have any impact on your regression analysis? Like, if it is not 45-degree slope but something different, then
So we haven't
in
checked
spite
that.
of being linear, it might be that basically it is not a very good result or maybe not very ideal.
Yes, that's why we didn't find any significance here. That's why we're trying to figure it out that but actually for analyzing this and for understanding this we need more data.
You had around 10,
Only 8.
only 8.
Yes, so if we collect more data, at least 25 to 30, so then only we will be able to find out that if this
Yes, the
angle.
data size is very small to compute.
Yes, that's the thing. Since this was just a pilot study, so just thank you.
Yeah, it's a good start.
Thank you so much.
Okay, so we thank the speaker.
Thank you to all the speakers and thank you Professor Bhumi for conducting the session for us. Now I would request Professor Pavitra Mitro of Indian Institute of Technology, Kanpur to please come on stage and felicitate Professor Bhumi with a memento. So we go for a break. Refreshments have been arranged outside the auditorium. We meet here again at 12:30 p.m. for our first event talk. Thank you.